So find the inverse of f of x equals 2x minus 3. Okay, well, let's see. I'm going to start this by, let's graph it. Okay, the square root, second square root, 2x minus 3. Okay, so it looks like it's a square root function, and it's been shifted to the right. Does it look like it's always increasing? So it should have an inverse. No problem with that, right? What would we say is the domain? I mean, the domain of this, it looks like it's starting here and going to the right. So, in fact, the domain is x is greater than or equal to 3 halves, sorry. And it looks like the range should be it's starting at y equals 0, and it's only going up from there. Yeah?
What would it look like if it didn't have an inverse?
It would have to go down or something in there.
If it's decreasing?
If it's increasing and decreasing in the same graph, right? In the same graph. So in any case, the thing to note about this is that this thing has a domain of x is greater than or equal to 3 halves. And you can solve this by setting it greater than or equal to 0 and find that. And it has a range of y is greater than or equal to 0. Now, what we know from the very first slide is that the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse, okay? So we're going to go ahead and find our inverse, but we need to keep that in mind for the end, and you'll see why. So I'm going to write this in a different color here. Right, this is for the function. For f minus 1, the domain has to be x greater than or equal to 0, and the range has to be y is greater than or equal to 3 halves. So, okay, now let's go through our steps. What's the first step of finding the inverse? Replace f of x with y. Next step. Interchange the x and the y. X equals 2y minus 3. Next step. Solve for y. Since y is inside the square root, we square both sides. Okay, subtract 3. Did I do something wrong? Add 3 to both sides, so it becomes x squared plus 3. Divide by 2. Y equals 1 half x squared plus 3 halves. Okay, and last, f to the minus 1 of x is 1 half x squared plus 3 halves. What's that? This x squared over 2? Oh, yeah. I don't care. I don't care. It's all the same. Okay, so now we have to look at the graph. Okay, let's see what happens if we put in the calculator. If we put in the calculator this function as the second graph. We know these are supposed to be inverses, right? So on the next line, I'm going to put the, remind myself, x squared over 2 plus 3 halves. X squared divided by 2 plus 3 divided by 2. And graph. Okay, now, do those look like one is a flip of the other across that line? They don't. But remember what we said about the domain of the inverse. It can only be for x values that are greater than or equal to 0, which means we don't care about this whole parabola. The only piece which is the inverse of this is this, because that's where x is greater than or equal to 0, right? So you have to take into account that we started with this as the domain and range, which means this is the domain and range. And that's why this piece here is not part of the inverse. And you remember how you can show that? In here, we could do like this. I'm going to second insert. I'll put a left parenthesis, and then I'll go on the right. Put a right parenthesis, divided by parenthesis, x, second math, greater than or equal to is 4, and that is 0. Right? And now when I graph it, it only shows me those two pieces. So it looks like one could be a flip across that line. Okay? So just keep in mind that that's how it works.